everyone. So in this module, we will be talking about how we can work with elastic load balancing. Here we'll be talking about how the load balancing is an important component of creating and setting up the application as a multi-cluster environment. So load balancing is an important component of any application deployment because using load balancer, we distribute the traffic coming from internet, or we can have the internal traffic distributed among n number of instances that we can add, because we never deploy the application on a single instance, because if the single instance goes down, if it is unavailable, then the application itself is going to be unavailable for the end audience, which we don't want. So that's why we prefer setting up the elastic load balancing. So here we can have a load balancer created, which we can use for automatically distributing traffic across multiple resources, where we can have a DNS generated once we create a load balancer, and using that DNS, the end users, they can reach to any instance that we have deployed in that specific cluster. So for working on load balancing, we do need something called as the launch template. And in terms of the exact distribution, what happens? So whenever anyone is going to work on any kind of application, they will be working with an internet-facing load balancer. So here, they will be required to work on a specific ELB. Now, this ELB is going to be accessed by the end user by using its own endpoint, just like when we try to access the instance by using its public IP address. So they will be accessing by using the endpoint. And then that traffic is going to be distributed among n number of instances. So in load balancer, depending upon the load balancer type, we also can create something called as a target group. So target group is nothing more but a logical group where we can add different targets like Lambda functions, EC2 instances, which are part of the same VPC, or it can be part of any other VPC by using their IP addresses. So a single target group can have up to 3,000 instances that we can add as per the requirement. So here we can have two specific components added here. So here, as a part of a setup, we can define one target group that we can name as target group 1, and then we can define another target group named as target group 2, where we can technically, if you want, we can have a single instance added, or we can even add a cluster of 3,000 instances in which the load can be distributed. So we can have the traffic distributed based on any logic. It can be distributed based on, let's say we have to divide the traffic evenly, then we can have an even distribution among n number of instances. Or if you want to have the traffic divided based on some kind of logic or rule, then we can also do that. Let's say we want to divide 70% of traffic to target group 1 and 30% to target group 2. So we can do that. If you want to have a listener-based distribution, we want, if traffic is coming to port 80, that traffic should be handled by this target group 1, we can define that. And if the traffic is coming to port 8080 or 8081, 8090, then that should be handled by another target group. We can even have a port-based distribution. Port means we can have a listener that we discussed, and we have the logical rule. It can be based on query string, the path. If you want that users who are coming to .com/blog, they should be handled by this instance, we can define that. If you want the users coming in from any specific path, then they should be handled by some other instance or group. We can even define that. So that kind of a complete control on distribution, how that is going to happen, is what we can achieve by using these kind of load balancers. Now we are going to look at the implementation of application load balancer, where we can have a complete rule-based distribution available as and when required. An application load balancer is the one that is going to support the HTTP and HTTPS endpoint. So here, as a part of a setup, we will be deploying two different target groups, having the load balancers configured on top of them, and then we will be deploying one instance in these target groups so that we can see how the entire distribution can happen. So for that, we have to navigate back to our AWS console, from where we will be able to access the deployment. So let's move on to the console here. So here from the console, we can navigate to EC2 dashboard. So load balancer does not have a separate service dashboard, unlike other vendors. So here we have a single dashboard for everything. So here we are currently going to make use of the instances. So here we'll be deploying one instance, and using that instance, we will be able to configure the setup accordingly, because we'll be able to configure our load balancer. We'll be able to use the same instance if we are going to deploy any application, and obviously we would require the applications to have the instances based deployment, because at the end, right now we are having touch base on Lambda function, but again, if we wanted, we could also add Lambda functions as a part of load balancer targets that we'll be discussing in our serverless environment. So to get started, first of all, we do need to have an instance, and then we'll be creating the target group, and then we'll be adding those instances in those two different target groups as part of the logic that we have discussed. So for working on that, we can navigate to the instance dashboard, where we can see the list of all instances that we may have deployed. And this is a region specific service dashboard that we discussed earlier. So we have to, first of all, launch one instance by clicking on create instance. Here we'll be deploying a simple web app on top of Linux environment, or we can even use any of the marketplace AMIs. So for example, here we can have a simple instance defined. We can name it as instance 2. Since we will be using 2 instances in each of those target groups, we'll be adding the name here as number of instances as 2. We can make use of any marketplace AMI if you want. For example, we can click on browse more AMIs. We can search for a predefined image available here that we can call as WordPress. So WordPress is one of the most popular CMS, as in content management system, available. So let's say here we can choose whatever images you want to work with. Like we have the WordPress and Ubuntu, we have from the cabinet, we have the diagnosis, we have supported images, we will be finding some multiple images from Vietnamese. So these are most popular images available that we can choose to work with, and then we can have it deployed accordingly. For example, here we can select this, we can click on continue, we can be able to see the cost that we also had to pay for using the image in case the image is completely managed or the image contains some kind of paid application components. So we'll be able to see that. Some are going to be free, some are going to be chargeable. So depending upon the vendor, what exactly we are going to make use of, we can get the price accordingly. So let's say for this hands-on, we will be using this Bitnami based image on WordPress so that we can have a quick deployment for our setup accordingly. So we can have it selected. Once you select the image, we can now configure the other parts. So here we can choose the instance type, what fits into our requirement and the budget, the key pair like we had discussed earlier. So these key pairs are going to be useful for getting connected to the instance by using the SSH client. So we can use any of the previous key pair that we may have deployed, or we can choose to create a new key pair as well. And then since we need 2 instances, we'll be clicking on launch. So these are going to be deployed in default network, and we will be able to get connected to them and add them to the target groups, because technically we don't need to create target groups to have the instances defined beforehand. We can have a blank target group created and we can add the instances later on. But here, as a part of a hands-on, we do need to see how the load is going to be distributed among those n number of instances. That's why we are trying to deploy the instance so we can see how we can connect to them to the target groups while we are going to create them. So the deployment of the instances will need some time depending upon how complex the images that we have selected, what kind of instance capacity we have with there, because that is going to decide the setup. So once the deployment is done, we can click on view instances. We can filter out the list of instances by using the instance state. Since we need 2 instances, we can name the instance as instance 1 and instance 2. So these are going to have the default deployment of WordPress. So if we try to open up the IP address, in a while, once it is completely configured, we will be able to see the instance will be opened up based on whatever inbound rule we had defined. Right now, as part of the default inbound rule, we have allowed them for HTTP access. So they will be made accessible. In the meantime, we can come back to the EC2 dashboard. So if we scroll down, we can see we have load balancer and then we have target group. So as we discussed, we are going to create two different target groups that we are going to add to the load balancer that we have currently deployed. So we'll be able to see the list of all previous deployments. So in case you want to remove them for a complete blank slate, we can do that. And we will be also able to see any active load balancer that we may have deployed. In case the load balancer is active, then we will not be able to have the instances, or you can say these target groups removed. And once we are successful in removing the load balancers, then we can go ahead and retry. So now we can start by defining a target group where we can add any kind of targets, be it instances, IP addresses, Lambda function, the application load balancer. So let's say here we can name it as TG01. Then we can define the VPC in which this is going to be part of. So if we are planning to launch the target group, then we always prefer using the same region, the same zone in which we already have the instances. Because if we don't choose that here, then we will not be able to see the instance being listed whenever we are going to add those target groups. And we can define the health check. So health check is also an important component of any load balancer, because health check is the one that is going to ensure that the health status of all the instances are going to be maintained. For example, whenever we are going to work with any instance, for example, let's suppose we had defined the ELB as in a load balancer. And now within the load balancer, we had defined two endpoints. We have instance 1 and instance 2. So let's say if one of the instances is not healthy, if this is down, and if the end user is getting served by using this instance, then the end user is going to see a blank page, or we can say an error page in front of them, because they have been served with something which is not available, which is not working as expected. So in this scenario, what we will be doing is we will be making use of health check by default, which is available for load balancers and all the target groups attached there. So health checks is simply keep on pinging the servers that we have here, so that in case suppose let's say if any of the instance is down, then that instance can be taken off the load distribution that we have here. And that is going to be a good thing when we are going to maintain the high availability of the application. And we want to avoid any kind of errors generated at the user's end. So that's how, and that's why we prefer setting it up. So now what we can do is we can go ahead and define when the instance should be declared as healthy, after how many consecutive pings it should be declared as unhealthy, what should be the duration of timeout. That means if someone has been pinged, then it is going to wait for how many seconds before it is declared as timeout, no response received, and the interval between different pings. So right now we can keep it all to default properties, click on next. And here we'll be looking at the instances which we had deployed. So here we have instance 1. We can click on include as pending below. So that is going to be added to this target group. Now, if you want, we can create another target group, keeping the instance as selection. We can name it as TG02, where we can choose the same HTTP traffic, because then only will be able to add, have them added up as a part of load balancer distribution. So once we do add target group 2, so we can see under target group 2, we have instance 2, and under target group 1, we have instance 1. So now we are going to map these two different target groups to load balancers. So for that, we can click on load balancer. And here we can click on create load balancer. Once we click on create load balancer, we can see the load balancer types in terms of application, network, and gateway. So application is the one that we use mostly for all the web-based applications, where we have only HTTP and HTTP supports available. So all the web-based applications, be it for mobile or for desktop, so they are being deployed by using the first application load balancer type. Second one is for network load balancer. This is mainly supportive of TCP, UDP, and TLS protocols, where we can handle millions of requests coming on a per second basis. Then we have gateway load balancers, mostly useful for the serverless environment. So here we can work with the API gateways, Lambda functions as a part of complete serverless activities that we are going to conduct. And then we have the classic load balancer, which is now deprecated, or against the previous generation. So here we don't have any kind of rule-based distribution. We can simply add n number of instances and have the traffic distributed among those n number of instances accordingly. So here we will be working with application load balancer. We can click on create, and here we can define the load balancer name. So let's say this is for application, so we can name it as application ELB. Here we can have two different type of schemes. We have internet facing and then we have internal. So internet facing is the one where we are going to have this load balancer exposed to the end user. So they are the ones, so their request is now going to be handled or gets distributed among the internet facing load balancer. So that is then going to take the request and distribute them among different target groups accordingly. And then we have the internal load balancer, which is meant for internal traffic. For example, if we are talking about the multi-tier architecture, so there we will be working with the front end. So multiple requests which are being generated by front end, they will be all sent to backend servers. If we have a single backend server, then that's not an issue. But if we have multiple backend servers, then we also have to have the load distributed among those n number of application servers. And that is achieved by using the internet or can say internal load balancers. So for any multi-tier architecture design principles, we always use these in combination. For the front facing, we make use of internet facing. For the in-house, or we can say for internal applications being distributed mainly from the different available web servers to different application servers. That's why we are going to prefer using internal. So here we can choose the network in which we are going to have these all resources deployed. So we always have to prefer the same network in which we have our main instance deployed. And here we can choose which zones they are going to be part of. If you choose, and if you don't choose anything here, then this is going to be deployed randomly in any availability zone. And if you want whatever instances we are going to make use of, they should be deployed in these only in these specific zones, not in any other region whatsoever. So there we can prefer using this. And then we have security group, that is what we have aligned for our new role, and then we can define the port protocol like we had earlier discussed. Right now, we want if the traffic coming to port 80, that is the default traffic, should be handled by target group 1. And here we can see the complete summary. In case you want to change the network, we can do that. Right now, we are going to keep it as same. Click on create load balancer. The load balancer has been created, and we will be able to see the endpoint like we had the nesting that we had talked about earlier. And then we will be able to pass this on to our stakeholders so they can get connected accordingly. Now, since this is application load balancer, so here we do have the ability to work with any role-based deployment. So what we can do is we can click on this option which says create load balancers. Now, once you click on create load balancer, we can choose the load balancer type. Or let's do one thing. We already have the load balancer. Let's do one thing. Let's define the role. Because right now we have only one rule defined, like we have HTTP 80, which is currently mapped to target group 1. And we want to set up a rule-based distribution like we discussed earlier. If someone goes to, let's say, page 1 in one specific deployment, then they should be handled by that specific group or page. If someone types in /page2 or blog, then that should be handled by another instance. So for setting this kind of rule, we can click on the listeners and rule section, click on the listener. So this is the default rule currently been defined. Now, as for the rule logic, as you can see here, if there is no path defined, for example, suppose if there is no path, there's no other rule defined, then the entire traffic is going to be sent to target group 1, which is the case. And similarly, now here we want to add rules. So we can click on add rule from the update section. And here we can give a rule name. For example, this rule is meant for, let's suppose, the blog section. And then we can add a condition. Suppose the condition can be based on the host header in terms of whatever header types. We have the distribution based on the get method as well. For example, we want to work with the, so here we can choose a path in case you want to have the traffic distributed based on path. For example, if the traffic is coming to start.com/page1, then it should be handled by some other path or other distribution. If the traffic is coming to page 2, then that should be handled by another group. So that kind of distribution is what we can have here. So for now, we are going to make use of path. Suppose here we can define a path. If the path is suppose, let's say .com/blog, for example, then we can click on confirm. So once we are in with this, we can click on next. We can choose the target group. So here this is going to be mapped to which target group. So if the traffic is coming to the .com/blog as per the logic that we define, we can map that to target group 2. And then whatever targets, it means whatever instances are currently available in this target group 2 instance, they will be distributed among, we can say accordingly. So here we can define the priority rule as 2. Click on next again. So now you can see we have 2 rules defined. If there are no other logic, then that traffic is going to be handled by target group 1. And if someone is going to type in, suppose it's a .com/blog based on the endpoint, then that should be handled by target group 2. So this is how the distribution is going to be. So first of all, we had to verify that the load balancer should be up and running, because just like the other setup, so this is going to be deployed, and once it is available as per the logic, so as you can see here, we have defined nothing. So here it is being sent to the home page or the WordPress deployment that we have done, as you can see here. And we do have a sample page, so we can see the sample page is named as sample-page. So we can do one thing, we can configure the logic for sample page, because we may not have the blog.html currently being deployed here. So that once the path is going to be blog, then that should be handled by the sample page. It's because sample page is something that is already there. Because if someone types in blog, then since blog is currently not there, so they may see the error page being thrown to them that in the blog, the traffic is still going to be handled by that, but it may not be sent to the right logic, the right rule that we define. That's how it's going to be. So here we are simply define the condition based on the path. If the path is supposed to say sample-page, then it should be handled by the other group or the other setup. It should be forwarded to target group 2 as what we had defined. Now, if we go back to the endpoint that is being defined by the load balancer, so by default, if we don't define any endpoint, any logic, then by default, it is going to be handled by this. And now if we define suppose .com/, let's say sample-page, then this is going to be meant to be handled by another group, which is target group 2. So this is going to ensure that the traffic is always going to be distributed among n number of instances as per the logic defined. And we will be able to see a modified version of analytics that we can achieve from the load balancer to see how many requests are being generated, how they are all currently being handled in terms of a small scale monitoring dashboard made available in terms of the number of requests, the response time. So they have been 6 requests so far, the rule evaluations, the HTTP methods based for the rule that we have created, so that we can understand it, we can analyze it as efficiently as possible. So this is what we have in terms of load balancer and target groups and how they can complement to each other and how they work with each other as a part of the deployment. So this is what we have in terms of load balancer. In the next module, we'll be talking about the auto scaling component. Thank you for watching.